When a battery is connected to an electrical circuit, it sets up an electric field between the two battery terminals. This field runs through the circuit conductors and exert forces on the charged particles inside the conductors. This causes charges to slowly drift through the conductors. This drift of charge is known as a current. By definition, conventional current is the flow of positive charge. So when electrons drift in this direction, current is considered to flow in the opposite direction. For a current in metal conductors, it is the free electrons that are moved by the electric field. Cations can't move because they are fixed in the metal lattice. These electrons drift from negative to positive. Thus, conventional current will be in the opposite direction. So, in all circuits, current is considered to be flowing from positive to negative, or high voltage to low voltage. Electrons in an isolated conductor are in constant motion due to the temperature of the metal, with speeds of around 1 million meters per second. This motion occurs in all directions and constantly changes as the electrons collide with lattice ions, resulting in no net drift of charged particles, meaning there is no current flowing in the conductor. When the conductor is connected to a battery, all the electrons are pushed in one direction by the electric field set up in it. Each electron briefly accelerates before colliding with an ion in the lattice. Upon collision, it loses most of its kinetic energy, and the process repeats. So, these electrons will have a velocity component along the wire, known as a drift velocity, and its value is minuscule compared to the one due to thermal motion. Drift velocity is responsible for the current flowing through the wire, not the thermal motion of electrons. Although drift velocity is very small, current immediately starts flowing everywhere in a circuit when the switch is closed. Why? This is because the electric field set up throughout the circuit travels at near light speed, thus takes an instant to set up throughout the circuit and get electrons moving everywhere. The loss of kinetic energy of electrons as they collide with ions in the lattice is called resistance of a metal. This energy manifests as heat in the metal, causing an increase in its temperature. The resistance of a conductor increases with length and decreases with increase in cross-sectional area. This constant is called the resistivity of a conductor and is different for each material. The work done in moving a unit charge between any 2 points within a conductor is defined as the voltage across that region of the conductor. Any resistance produces a voltage drop across itself since work is done in moving a charge through it. So, the voltage supplied by a battery is rationed amongst all the resistances in the circuit and is used to push the current through each of them. The current flowing through a section of an electric circuit is related to the voltage across it through Ohm's law, which states that the current through a component is directly proportional to the voltage across it. The constant is the resistance of the component. Resistance depends on temperature, so this law requires a constant temperature. Ohm's law is essential in solving for unknowns in electrical circuits. In general, connecting leads in circuits have very small resistances, thus produce negligible voltage drops, which can be neglected in calculations. There are special components called resistors, which provide a larger range of resistance. Resistors are crucial in controlling currents in circuits, and they can be arranged in one of these two ways, or a combination of both. For resistors in series, the voltage of the battery is split amongst them, and the current flowing through each one is the same. The equivalent resistance of these resistors is the sum of all the resistors in series. So, overall resistance is always larger than any of the individual resistances in the branch. For resistors in parallel, all the branches are connected to the same points within the circuit. Since electric fields are conservative, work done in moving charges between these 2 points is the same, regardless of the path. This means that all the branches have the same voltage across them. The current in the circuit splits amongst the branches of resistors. Current chooses the path of least resistance, meaning more current flows through a low resistance branch than a high resistance one. Resistors in parallel are related to their overall resistance by this equation. This tells us that the overall resistance is always less than the smallest resistance in the network. To measure current flowing through any circuit component, connect an ammeter in series with said component. To measure the voltage drop across it, connect a voltmeter across it. That's it for the basics of electrical circuits. If you enjoyed the video, please leave a like, comment, share, and subscribe to the channel for more content.